So we're starting off today with the worksheet called the birthday gift. Whoa. Let's zoom out a little bit. Susan's grandmother gave her $34. Instead of spending the money, Susan decided to save the $34. Each week she plans to save an additional $250. This seems very familiar. It's on purpose, right? It's on purpose. Right? Yesterday we talked a little bit about recursive stuff. We talked about the first term and how often it changes and what those kind of things look like. Okay? Today we need to talk about a process. Okay? We thought about that yesterday, but we didn't really talk about it so much. So if we're thinking about a process, what are we talking about? Look what pen I'm going to use today to fill in my paper. See? Pen. Nunchuck pen. Be nice or I'll hit you with my nunchucks. Not really. And for the record, they don't hurt that much. Okay. 0 weeks. I have $34. What was the process? I had 34, right? 1 week. What's the process? 34 plus 250. Which was what? 36.50. 2 weeks? What about that? Can we do that instead? Do you mind? Even if you mind, this is what we're going to do. I'm just saying. Do you see what I did, though? I took what I started with and I did what? Because that was last time, right? So I needed to add another 50 because it was another week. And what's that? 39. Then what? What's next? Week 3. 34 plus 250 plus 250 plus 250. What's that? Good. 41.50. Week 4. 34 plus 250 plus 250 plus 250 plus 250. How many 250s? Really? Huh. That's interesting. Well, what's the total amount of money here then? 44? Okay, wait. So on week 5? I know what we talked yesterday was just adding to the next term, right? But what's my process here? 34 and what? 250s, right? How many of them? Are you sure? Like that? So on week 5, there were 5 250s? And week 4, there were 4 250s? And week 3, there should be, oh my gosh, 3 250s. This can't be like a clue or something, right? Or can it? Dun dun dun. What is this? 46.50. Write a function rule for the amount of money she'll have after T weeks. Well, if it wants a function rule, how do I have to start it? F of x, right? Function rules are f of x. What did she start with? Wait, I have a 34 every time, don't I? So we start with 34, and then what? Plus 250 T? Wait, how many weeks is T? I don't know. So is it okay if I just call it T? And you told me a second ago, whatever week it is, that's how many 250s they are. So is that okay? Yes, it's amazing. Find a viewing window for the problem situation. We don't have the calculators out yet, so we just skip this problem, right? No. And the reason we don't is because we're going to have a conversation about this. And we're going to have a long conversation about this. Maybe not that long, but longer than normal. Because if we have this conversation now, when it's time to sketch a graph when we do get the calculators out, how quick is it going to be? Yeah, you're already going to have an idea of what these need to be based on the problem situation. We're not going to have to sit and toil over a graphing window. Okay? So let's start here. X min, what does that mean? The lowest point on your x-axis. Very good. Okay? For this problem situation, what does the lowest point on my x-axis need to be? Which of these columns represent my x values? Here, right? What is the lowest it needs to be? Very good. 0. What is next? What does this mean? The highest x value need. X maximum, right? X max. What's the highest my x value needs to be? Now, are we smarter than the calculators? Yes. They'll only do what we ask them, right? So we have to be smarter than they are, and we are. So we're also smarter than these problems, aren't we? Okay? So like right now, what's your first guess or your first instinct about what you want your maximum to be? 5, right? Why do you want it to be 5? Because that's where the table ends. But without reading down any further, thinking about what happened yesterday and the day before, what's going to be one of the questions if my table goes from 0 to 5? Like what's 7 or what's 8, right? So can we plan ahead for that? Can we outsmart our calculators? So what do we want our x max to be? 10 would be great. 10 would be great. What is this? It's the scale. What does that mean? Like, how do we count by? Right? If we're only going from 1 to 10 on our x-axis, can we count by ones? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can we count by 2s? 2, 4, 6, 8, 10. What about 5s? 5, 10. We can, but is the best use of our space. We want enough tick marks here to know that what we're going on. So if there's a dot right here, I can like trace like my pencil or my pen down to the page and see approximately what my x value is, right? So what do you think would be the best choice for my scale right here? 1. Very good. Y minimum. Based on this problem right now, what's the lowest y value we want? I'm hearing lots of 34s. Okay? And in some cases that would be okay. I also heard a 0. In some cases that would be okay. Just like I was trying to tell you yesterday, I'm going to try to tell you it again today. Is there one right answer for this? What I'm trying to get us to think through is the best for this problem. Does that make sense? Okay? If I make this bottom corner 34 and I draw my line, we know what it's going to look like because we already did it yesterday, right? With the recursive kind of talk, we know it's going to be increasing like this, right? What I'm afraid of is that you would see this point down here and forget that you put your scale at 34 and think it's 0. Okay? Some people said 30. So that means it'd start like right here and go up, right? That might be okay depending on the situation that we need. But maybe for this problem, where might we start? Sean? 0. Okay? Probably it's a good idea to start at 0 because that's going to give us a really accurate picture of where it started, where we went to 34, and then where it increased from there. Fair enough? But for the record, if I had you do this like on a quiz or a test and you put 30 here, I would not count it wrong. I wouldn't. because you're just looking at that one particular picture. This way we see a little bit bigger picture. Fair enough? Okay, what about y max? For the record, this is typically the one that people have the most trouble with. So I want you to understand that you already gave yourself a hint. You already chose an x max that made sense in this situation because that was pretty easy to see. What if we put x in right here as 10 for t? That would be 25. What's 25 plus 34? 59. So what might be a good y max? 60 would be really good. Do you see where it came from? I didn't just randomly say 60. I used what I already decided on for my x max. Okay? Now here's the tricky part. Is that how we're always going to do it? No. Okay? But I'm trying to get you to think about the different things that you're going to think about when you're making a window. Okay? What about y scale? The scale, right? Do we want to count by ones again? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All the way to 60? No. That's too distracting, isn't it? What'd you say? 10 would be okay. 5s would also be okay. Either one. What do you want to choose? 10? All right. Just for the record, if any of you guys are working with anybody in third period on this stuff, we put 5. Just saying. Again, there's not a right answer for this. There's like a better answer or something like that. Okay? All right. Justify your window choices. Excuse me, graph. I just did. Didn't we just justify them in our whole conversation? So what were our justification for our x min and max? X min and x max lets you see 10 weeks. Is that an okay justification? Y min and y max lets you see the values given for x. And before we get going too far, let's graph this. We said that was 0 and we said that was 10, right? And how did we count? By ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We said this was 0 and this was 60. And how did we count? By tens. 10, 20, 30, 40, 50, 60. So if we are starting at 34, 10, 20, 30, it's a little bit above 30, right? And it's increasing. Oh my gosh, we just did that entire problem without a calculator. We are geniuses. Now for the record, am I ever going to get the calculators out? Heck yes. Heck yes. Not even just regular yes, but heck yes. Okay? We don't want to get bogged down with so much of the arithmetic that we lose what we're doing. Okay? We want to be able to do applications of this stuff. Now, use your graph and the table to find the following. Now, again, we don't have our calculator, so we may not be using the table, but I'll show you what we mean in a second. How much money will Susan have after 7 weeks? Do we have anything we can use? Our equation, right? Okay? Or our other paper from yesterday, don't we? Okay? But just for argument's sake, let's go ahead and put it into our function rule. F of 7, because that's what our week is, right? Is 34 plus 2.5 times 7. Somebody please tell me why people freaked out earlier about this. What did I do? I didn't write the 0. Are you guys going to be okay with that? Never. Excellent. Okay. So what is 2.5 times 7? Guys, what's 7 quarters? How much money you have if you have 7 quarters? 4 is $1. 3 more. $1.75. So what's that going to be? Take it back into context. We have 1 decimal place. 1750, right? So we have 34 plus 1750, which equals 5150. Good. Susan wants to buy a school ring. When will she have enough money to buy the $139 ring? How is that different? Yeah, this time we know the money, don't we? So we know the 139. We have to figure out how many weeks. So what are we going to do here? So subtract 34. 105 equals 2.5t. To divide by 2.5. It's going to go to 100 4 times with 50 left over. 2. So what's the answer to the question? 42 weeks. Okay, any questions so far? Number 7. Write the coordinates of the point where the line intersects the y-axis. What are the coordinates of that point right there where the line intersects the y-axis? Okay, that's what I was afraid you'd say. I was afraid you'd say 34. What's it asking for? Where it crosses the y-axis, it's asking for the point. 0, 34. I know that seems a little picky, but I don't care. We got to do it right, don't we? Okay, very good. Those of you who said 34, I was not trying to make you feel stupid. Okay, I'm trying to get you to answer the question correctly. Fair enough? Remember, if I want you to feel stupid, you will know. This point is called the y-intercept. What does this point represent for Susan? After 0 weeks, Susan had $34. Whoops. Very good. How will the line change if Susan deposits only $15 of the $34? Okay, hold on. This is where it was before, right? This is where it was before. If her starting point is only $34, what does the line look like? Like that, right? So what changed? The position of the y, so the y-intercept changed. What did not change? The slope. Why did the slope not change? She's still saving $2.50. Excellent. She's still saving $2.50. Okay, so what's the new function? F of x equals 15 plus 2.5x, right? We okay so far? How will the line change if Susan deposits the $34 from her grandmother plus another $15 she already had? So here's the original line. It's 15 higher now, isn't it? So this is 15 lower. It's minus 15. but this is 15 higher. What does that line look like? What changed? The y-intercept, it started higher. What did not change? The slope. Excellent. What's the new function? Good. F of x equals y49. You can go ahead and add those two together. Good. Plus 2.5x, right? Good. How will the line change if Susan deposits the $34 from her grandmother but decides she can only save $2 a week? Okay, here's the original line. This time we're starting at 34 still, but show me with your arms. Show me with your arms. Where's the original function? Put your arm with the original function. And now show me only $2 a week. Oh my gosh, you guys are amazing. Like that? Excellent. So what changed? Slope. What did not change? The y-intercept. So give me a new function. 34 plus 2x, right? I guess if we were doing these from the front, I'm sorry I missed it, but if we were doing it from the front, well, no, that's true, because at the front we had t, right? Up here we had t. So really, can we go back and change something on the front real fast so that I get it right for you? This should really be f of t, because it's telling us what variable we're using, and if it wants us to use t weeks, we have to say f of t. Okay? That's why these are okay, even though I was a little worried to begin with, because we said f of x and then we used x. Fair enough? Okay, look at 11. What changes in the situation resulted in the change of the steepness of the line? Amount she saved. Does this result in parallel lines? Are these lines parallel? No. No. What changes in the situation resulted in a change of the starting point of the line? Amount she began with. Did this result in parallel lines? These and these? Yes. Sales goals. We got to think back for the last couple days. This is kind of a review for us, plus some of today's as well. Notes. A local clothing store sets weekly sales goals for their employees. The graphs show the first quarter results for 4 employees, actual sales and sales goals.
Yo, Kingston.
What's up?
Can you send me Hayden? She's leaving.
I will.
Thanks, homie.
Word out. Hayden, some gangster is calling you to the office. Okay, thanks. Okay, which consultants most often met and exceeded their goals? Met and exceeded their goals. Where does it have to be if they actually exceeded their goals? On met is on the line, but where is exceeded? Underneath it, right? Met or exceeded is underneath because their actual sales was here and their goal was here. So they met it or exceeded their goal. Okay? So who's it going to be? Enrique? And Amber. Good job, Amber. Which consultants most often failed to meet their weekly goals? Did Moesha fail to meet her goals? It's just Seth, isn't it? Poor Seth. Which consultant most often matched their weekly goals? Moesha. Very good. And why is that again? Because her dots are on the line. Okay? Which consultant had the higher goals? Where are the points if they're higher goals? So who is it? Moesha and Enrique. Which consultant had the lower goals? Only Seth? And Amber too, right? Sketch a graph of a consultant who has low goals and consistently matches them. If they consistently match them, where are the dots? On the line. And if the goals are low, where are they? They're like down here, right? All pretty close to the line, some of them on the line, right? Sketch a graph of the consultant who has high goals and did not meet them. High goals and did not meet them. So the goals are high up here. Where are they going to be if they didn't meet them? Above it, right? Above it. So maybe like that. Is that okay? Just for the record, whatever we don't finish here before the bell ring is your homework. Okay? Now I'm going to zoom in a little bit because it's a little easier to see if I do that. These are some calculator screenshots. Can we figure out what kind of saving or spending plans are just based on these screenshots? Tell me about this one. Started at 50. Added $3.50 each time. Now we don't really know how much time it is, so that's why I said each time. We don't know if it's a week. It doesn't say that in the instructions or anything like that. Fair enough? Okay. So what about 9? Ooh, 9 gets weird. Look, that's not a parenthesis, is it? That's a bracket. So let me explain this real quick, and it'll help with the rest of them. That first 0 is like time is 0. And that number right there is how much we had when time was 0. So what did we start with? Started with $99. What happened to this second term every time? Can you tell we subtracted? $199 each time. Does that make sense? I know it's a little muddled, but I need you to be able to decipher stuff like this. Okay, I'll be there to help you, I promise. But we subtracted $1.99 each time. So what happened on number 10? Started with, what, 82.30? Is that what you said? It's supposed to be 82.30 is what it's supposed to be. I don't know. I know it's kind of hard to read right here, but it is 82.30. Then what happens? What's happening right there? Added 15 each time. You guys are doing really well on this. I'm very proud of you. Okay? Look at 11. How much do you start with? Okay. And then what? Excellent. Each time. And the last one? For this last plan, what does this point mean? At 10, we don't really know what the time period is. Can we go ahead and say weeks? I mean, that's what we've been dealing with on all of our other problems. So I guess let's go ahead and say that right now just to keep from getting confused. At 10 weeks, what? And with that, we're done. So on Monday, when you get here, I will check this homework. Make sure this homework is done. This one right here. I'm going to check this homework. Make sure it's done. Peace.